Hello, everyone. My name is Holly Hake, and I am a fifth-year neuroscience PhD student working with Andres Stocco here at the University of Washington. And I want to tell you all about our new paper called Breaking New Ground in Computational Psychiatry. So this field and the development of tools for precision medicine is something that we're very interested in. And specifically, this project is all about using a computational cognitive model of memory to help diagnose memory impairments. And let me tell you all about how this got started. So right now, if you felt like if your memory was starting to degrade, you could either go to a hospital or a research clinic. And at that research clinic, they would have you undergo a full clinical evaluation. Let me show you what that looks like. So this clinical evaluation involves your full health history, your family members' health history, specifically ones that suffered with memory impairments as well. They would do a clinical dementia rating score for you, and that looks at several aspects of cognition. Then they would do the gold standard of memory diagnostics, which is the Montreal Cognitive Assessment, or MoCA. And then after that, the individual would undergo a full neuropsychological battery that looks at all of these different aspects of memory. And then lastly, a neurological evaluation. And if you're an individual who personally feels like your memory is starting to degrade, then hours and hours of testing could be pretty disheartening for you, especially if you are noticing that you're performing poorly. So that's on the individual side. And then on the research side, after all of that, there has to be a general consensus. So a group of MDs and PhDs and all of the research staff get together to form that ultimate diagnosis. And overall, this could take about 50 hours of labor time for just one person. So because of this, our goal was to see if we could develop a tool that is fast, repeatable, and reliable, and could be used to diagnose these various memory impairments. We started with one of our collaborators from the Netherlands who had developed this app called Slim Stampin'. So this app is an adaptive fact learning software, and it's used to help optimize student learning. So it gathers information about them and then figures out the best possible time to introduce new facts and stuff to them. And we thought, if this is essentially, learning a lot about an individual's memory, then why not use it as a potential diagnostic tool? And that's what we did. So to give you a feeling of how the interface looks like, this is a video of an individual going through the various lessons. This particular lesson is on pastas, and the specific type of memory that they're getting tested on is their recognition memory. So that's the multiple choice, but we can also do recall memory, which is the verbal recall. And, this lesson is all on buildings, this one's maps. And so while an individual is going through this, the model is learning a lot about them. It's paying particularly close attention to their response time and their accuracy. And it is figuring out, which items are harder, which items are easier for them, and then tries to introduce them at the most optimal time. And in a sense, the model is creating a digital twin of this person, a digital twin of their brain, of their memory. And the way it does this is by modeling the probability of retrieving a particular memory, so like a memory of a fact, over time. To add more math to this, so specifically, we're looking at the activation or the odds of retrieving any of the memory traces at a specific time. Each of the traces is each of the times that an individual was exposed to a specific fact. All of these traces sum up to form the memory. And more importantly, all of the traces decay at different rates. And that's what we care about the most. So alpha, or the decay intercept, is what we will be calling the speed of forgetting. This is a calculated model parameter. And essentially, the speed of forgetting explains the relationship between the history of a memory and the likelihood of being able to retrieve it in the future. And ultimately, this suggests that by looking at the history of a memory, the number of times it was assessed, it's possible to determine the rate at which a memory is forgotten. And then we kind of generalize that to how they tend to forget in general. So their general speed of forgetting. So this equation was taken out of the declarative memory module within the ACT-R cognitive architecture. This is an architecture that tries to explain through computations the way the mind or cognition arises. So there's a lot of, more contextual framework here as well. So for our project, we had two target populations. So we started from taking from the Alzheimer's Disease Research Center here at the University of Washington. There are multiple units of these all throughout the US. And we cared about just individuals between the ages of 55 and 85 with normal healthy aging, but also individuals with mild cognitive impairment. So that's like one step above. And we wanted these individuals, one, because we knew that we wanted to have the individuals in our study for about a year to track their longitudinal trajectory. So we needed individuals that could still be performing the task and pretty functionally well for at least a year. And then also because these people with mild cognitive impairment are on track to developing Alzheimer's or dementia within the next 2 years after diagnosis. So we thought this would be a really good population for potential intervention methods as well. All right, because we were keeping them in the study for a year, we were testing them every week. We needed to come up with a whole bunch of categories of lessons. These are the type of categories that you'd find in trivia, I would say. So art and architecture, language, culture, science, technology, history, entertainment and media, geography, nature, wildlife. We did this because we wanted to maintain participant attrition and also look at different aspects of memory. I think you would also find that you can remember different types of things differently. You can remember maybe dates or different languages worse than other words, and also as well as motivation. So that is definitely a future goal, to parse out how motivation plays a role in memory. And to contextualize what this speed of forgetting parameter is, we have a whole bunch of healthy undergraduate students here at the university take the exact same tasks, and then we got their average. And their average was about 0.3. So if you have a 0.3 speed of forgetting, then that means if I introduce a fact to you and then 6 hours later ask you what that fact was, there's about a 5% chance probability that you'll be able to tell me what that was. Okay, so now let's look at some of our data. So in our cohort of about 25 to 50 individuals, we found that there was a range average of about 0.37 to about 0.43. And that was pretty consistent for all of the lessons. It didn't matter what the individual lesson was as much. So once you got a speed of forgetting of a certain value, let's say 0.37, it tended to stay pretty much stable throughout the year. And to give you the actual data on that, how reliable is this? When we ran a test-retest reliability, we found that there was a correlation coefficient of about 0.7, so very highly correlated. Once you get that initial 0.37 speed of forgetting value, you probably tended to stay in that value or within a very small range of that value throughout the year. So then what we care about the most, how diagnostic is the speed of forgetting? So when we take that data and then split it into our two groups, this is what those speed of forgetting values looked like for each of the lessons. And you can see that there's already quite a bit of a split between the two groups. And we found that healthy controls tended to have an average of 0.37. And if you remember, the undergraduates were about 0.3. And then for mild cognitive impairment, about 0.43. To contextualize that again, if I were to ask the healthy control individuals to remember that fact, they'd probably have a 5% chance of remembering it in an hour. And then for our MCI cohort, 5% chance of remembering it in about 20 minutes. And then we did have some individuals that had dementia that we tested separately, and their average was about 0.53. So they only had a 5% chance of remembering what that fact was after about 5 minutes. So then we wanted to look at the classification accuracy of this. This is what you would do if you want to see how diagnostic is this tool. So essentially, this is like a binary classifier. We toggled through all of the potential values of the speed of forgetting and then looked to see what the classification accuracy was. So for instance, if an individual had a speed of forgetting of 0.38 and up, then they were likely MCI. And at that point, they were able to correctly classify MCI versus healthy control 82% of the time. And then you can take the total area under the curve. And what we found is ultimately, if we look at all 52 lessons, if we averaged all of them together, then we had a speed of forgetting classification accuracy of 93%. And that's great, but the whole point is we want to try to make this as fast as possible, as convenient as possible. So what happens if we just look at a single 8-minute lesson? Not a year's worth of lessons, but just a single 8-minute lesson. With that, we find that we still have a very high classification accuracy, being able to accurately diagnose our participants about 86% of the time. Then we wanted to compare it to that gold standard memory measure that I was talking about, the MoCA. And when we look at this, we find that the speed of forgetting was very highly correlated with the MoCA. This is something that in the clinical realm will be very sellable to these clinicians. So the main take-home messages here are we can indeed extract an idiographic memory parameter, and we can diagnose mild cognitive impairment with about 86% accuracy in just 8 minutes. So overall, this tool is fast and it's repeatable and very reliable. And with that, I would just like to thank my whole team, the team here at the University of Washington and the ADRC, and then of course our collaborators that originally developed the app. Thank you very much. And now I can take any questions.